What's going on, guys? Welcome back. Today we're going to talk about security information event management tools. So basically today we're going to give an introduction about SIEM tools, and as you can see, guys, we're going to talk about 4 items: definition, type of log sources, the collection and normalization, and lastly the analysis and alerting. Okay, so let's first talk about the definition of the SIEM, or security information and event management. So SIEM are tools, collects data from various devices, endpoints, network devices across the network, and then it stores them in the memory. So basically all of the logs in your network. So say you have here, let's say you have 15 Windows devices, and here you have 10 Linux devices, and there you have one web server, and here you have firewall. So what you can do, all of these devices generate logs. So these devices generate logs all the time. It's like this. Let's remove that. So all the time, in real time, you have logs generated. So instead of analyzing the logs at every single device, why don't we send all of these logs to a central place, a dedicated device that have SIEM installed? SIEM will collect the logs from various log sources, stores them in a centralized place, and then SIEM, what it will do, it will normalize, analyze, and alert the security analyst. So the benefits are countless. So first, we save time. Instead of analyzing the logs individually, we analyze them from one single place. We define rules for what is suspicious and what is normal based on the network baselines, and then we create, as you can see here, alerts for the we create rules for the analysis and the alerts. So that's the definition of SIEM tools. They are not devices, they are tools. Example of SIEMs, we have Splunk. Splunk is a SIEM tool. Also you have QRadar. These are SIEM tools. And if you watched my series on Splunk, you will understand more about the importance of having SIEM installed in a corporate or an enterprise network. Now, having talked about the SIEM and the importance of SIEM, let's now talk about the type of log sources. So what kind of logs the SIEM analyzes? What kind of logs the SIEM stores, collects, and analyzes? So here we go, the types of sources. So in general, we have 2 types of sources. We have host logs, host-centric logs, or we have network logs. Let's talk about each one of these log sources in detail. So if you open a new page here, and here we talk about the host logs. So it's self-explanatory. Host logs are the logs generated within a host or a machine. Say it can be Windows or it can be Linux. In Windows, all logs are stored in something called the Win event log. In Linux, logs are stored in much different places, depending on the type of logs. For example, web activity logs are stored under var log HTTPD. All HTTP request, response, and error logs. If it is cron jobs, scheduled tasks logs. They are stored under var log cron. So here we can see events related to cron jobs. They are stored under this location. If we want to see authentication logs, authentication logs are stored under var or var log authentication.log. In some cases you can find them under var log source. And if we want to see kernel logs in Linux, they are stored under var log kernel. So in Linux, pretty much everything under var log, okay, can be actually anything, any type of logs: web activity, cron, authentication, kernel. Okay. So these are examples of host-centric logs locations where you can find them. Now let's look about the actual type of logs that are generated in a host machine, say Windows or Linux. For example, 1. If a file is being accessed, file access or modification. This is a type of log that's related to a host, right? It's not a network log. Next, we have process execution. That is another example of host-centric log. 3, we have user logs in, right? That's also a host-centric log. These are examples of host logs. Now let's talk about network logs. Network logs. What are examples of network logs? Examples of network logs: first we have SSH access. So someone logs in, logs out, attempts to log in, failed logins, successful logins. They are all SSH logs, and they are network-centric logs. 2, we have web traffic. Web traffic, even if it happens on a host level, it's still considered as a network-centric log. VPN activity, and another example is file sharing. These are all network-centric logs. So imagine you are sitting down at every single device and analyzing all of these logs in all of these locations and all types of these logs. It's going to be a waste of time. All of these logs will be gathered at a single place in a dashboard using the SIEM, Security Information and Event Management. So it's, guys, that's the importance of Security Information and Event Management: central analysis, central collection and normalization of all types of logs in a single place. It can give you real-time protection, real-time detection, not protection at all, detection only. 24/7 monitoring, protection against the latest threats through the analysis. So what you will do as a security analyst, you will install the SIEM. Okay, SIEM will gather all of these logs, okay, normalize them. So the first step is, first we gather. So SIEM gathers, then it normalizes. After the normalization, okay, it analyzes, and the last step is to alerts you. So the SIEM will gather and normalize, and how it analyze. The analysis is based on something called the conditions set into rules. So we create rules in the SIEM tool. If the rules exactly, they have conditions. If the conditions are met by these logs, it will generate an alert. Okay, that's how detection or security detection works in a SIEM tool. So now, having talked about the type of log sources, having talked about the log collection and normalization, now let's talk about how the SIEM analyzes and alerts. So we gave a hint about something called the rules. Let's explain the rules that are configured in the SIEM. So SIEM rules. So these rules, the first thing, they are logical and conditional, meaning all of these rules have an if statement. If a condition is met, do something, do X. Okay, if a condition is not met, then do nothing, just skip to the next traffic, next packet, whatever it is. Okay, that's how it works. An example of a rule, let's give an example. So for example, a user tries to log in for more than 10 seconds. So let's say user, okay, trying to log in or generates 5 login attempts under 10 seconds. All of these login attempts are failed. Okay, so what I can create if, okay, if a user tries to log in, okay, more than 5 times under 10 seconds, and if it happens all of these attempts are failed attempts, what I will do, I will generate an alert. So do X here. Most of the time, 99% of the time, it is alert, generate an alert. So if this happens, if this condition is met, I generate, or the SIEM generates alerts. That's the rule that you create in the SIEM. Okay, it doesn't happen automatically. Another type of rule can be, okay, successful login after, say, 10 failed attempts. It's very clear indication that this is a brute force attempt, successful one. So I can create a rule saying that if a successful login attempt or successful login happens after 10 failed attempts, what you will do X. The X, most of the time, it is generating an alert. Now, what's going to happen here? After all of these rules, after you have created all of these rules, that's how the SIEM, or that explains the analysis phase in the SIEM workflow. And that explains how the alerts are generated. Now, in all SIEM tools, guys, all of the alerts, the statistics are gathered in the dashboard. It's the place where you will see the most important statistics about the activity happening in your network. Okay. Now let's take a practical example and demonstrate this in action. So let's take this here, and we have this lab work, task 6, from this room, intro to SIEM. So let's view the site. Okay, let's read through this. In the static lab attached, a sample dashboard and events are displayed. When suspicious activity happens, an alert is triggered, which means some events match the condition of some rule already configured. Complete the lab and answer the following questions. Okay, so here we see a typical SIEM dashboard. We talked about dashboards. Click on each visualization to receive a more detailed explanation of what the visualization is displaying. Start the activity. As you can see, this is an example of SIEM dashboard. Okay, we have statistics about the network activity, and here we have the processes generating the events, the ports and IPs, the number of events. So if we click here on start suspicious activity, As you can see, we have here an alert. Potential crypto miner activity observed. Find and click on the triggered event to show the details. So how this is generated, we explained how this is generated. Okay, logs are gathered and normalized. They are compared to the rules we configure in the SIEM, and if a rule is matched, SIEM will generate an alert. The alert is shown in the dashboard, either through a process or IP or destination. So we click on the process that is generating the alerts, and here we see the related events. Look through the event log to find the event that triggered the alert. So here we have various events. We want to find the malicious one. So we already have one given info about the malicious event, which is the process name. If we go to process name column here, we can see the process name, Kudo miner. So that gives the answer for the first question. Click on start suspicious activity. Which process caused the alert? It is Kudo miner. Find the event that caused the alert. Which user was responsible for the process execution? So here we are analyzing the artifacts related to the malicious event. So now we capture the process name. Now we get more information about the host name, the username, and all other connected information. So we have the username here of the machine, Chris Ford, and we have the host name of the machine. This answers the following two questions. And here we have examined the rule and the suspicious process. Which term matched the rule that caused the alert? Again, guys, we explained that all of these alerts are generated by when the logs match the rules configured. So let's take a look at the rule that triggered this alert. So we click on this event, and here we see the rule that the analyst has configured previously. As you can see, this rule says that alert with the following. So it's going to say the alert statement is potential crypto miner activity. Now if the if statement, now the content of this statement is this: event ID has to be 4688 and log source has to be Windows event logs, and another condition, the process name equal. Now here the process name, this is a kind of regular expression, so it has to contain miner or crypt. If all of these conditions match, we're going to raise an alert that potential crypto miner activity is detected. Now let's take a look first at what is event ID 4688. Let me see if I have it in my notes. Yeah. So 4688 is a process creation. If you go back, it means that if a process is created and the log source was Windows event logs and the process name or the name of the process contains miner or crypt, then raise an alert that the crypto miner activity is detected. So yes, how the rule is triggered. Now if we get back to the dashboard, we saw that the alert has been raised by a process named Kudo miner. So it must be that SIEM matched the alert based on this condition, because the process name contains miner. Okay, it matched the condition set in this rule that the process name either contains miner or crypt. So examine the rule and the suspicious process. Which term matched the rule that caused the alert? It is miner. Okay. Now say that if miner did not exist in the rule, okay, there is no chance the alert would be raised. Right? Simply because event ID 4688 is a process creation. And whenever you launch a program or application in your PC, a process will be created. We're not going to raise an alert whenever a process is created, right? So 4688 is not always indicator of malicious activity. Let's now go to the next condition. Log source equal Windows event logs. Okay, that's also not indication of malicious activity. Now process name contains miner or crypt. If the attackers were smart enough, they would change the name of the process from kudo miner to something that resembles or looks similar to a process in Windows. That way the alert will not be matched. But of course, you can create more advanced rules to match the malicious activity. And that's how threat intelligence comes into action. You have to understand and study the attacker's profile, adversaries, their techniques and procedures, and the malware they create. And that's how we create the rules here. Okay, what's the best option that represents the event? False positive, true positive. False positive, it's a false alarm. Okay, say you have a process, okay, that matched a rule configured in SIEM, but the process is actually not a malicious one. So it's false positive. True positive is the actual malicious one. Selecting the right action will display the flag. What's the flag? So go to analysis action. How would you like to action this rule? True positive, and isolate the host. Isolate the host means that we detect a malicious activity in a certain host. Now the incident response process starts and we isolate the host. Save action, and this is the flag. I hope you guys find this tutorial helpful, and I hope you now become more familiar with the idea or concept of SIEM. In the next videos, we're going to talk about Splunk. We already talked about Splunk in the previous videos, but we're going to introduce more tutorials, practical ones about Splunk. Thank you for watching, and see you later.